Dr. BrianCox robs Georges Lemaitre to glorify Einstein. Is this really necessary? Presented by Dr. Marco Pereira, creator of the hypergeometrical universe theory. Welcome. Today we highlight a common Internet myth, one echoed even by renowned physicists like Dr. BrianCox, who claim that Einstein predicted the Big Bang. This is historically false and scientifically misleading. The question I have: do I have to become a conman? What I see is people telling you tremendously stupid things with perfect confidence. That is the opposite to what a scientist should behave. Science is about leaving the question open and ask for the simplest and best model. Science is about presenting the reasoning behind the conclusion and not just the conclusion. One should never steal the fruits of labor by our great scientists to give them to a preferred one. We should not behave like cult members. Our behavior should make sense. Historical clarification. Who actually predicted the universe's expansion? Einstein did not predict the Big Bang or an expanding universe. In fact, when presented with evidence of cosmic expansion by Georges Lemaitre, Einstein initially rejected it, calling it abominable. It was Lemaitre, a Belgian priest and physicist, who correctly interpreted Hubble's redshift data as evidence of an expanding universe. Einstein preferred a static model and introduced the cosmological constant to force that result. Cox's misrepresentation. Dr. BrianCox, Einstein's general relativity predicts the Big Bang. Dr. Cox suggests that the Big Bang was a natural prediction of general relativity. This is revisionist history. Einstein's field equations allow for many solutions, including static and dynamic universes. It was Lemaitre, not Einstein, who saw that GR implied expansion when paired with Hubble's redshift. Even Alexander Friedmann had derived expanding solutions before Einstein accepted the idea.
You have a theory that tells you, if you put a sun there, a big blob of mass, it tells you what happens to space and time, how it curves. So in a sense tells you the story or the history and future of a solar system. So Einstein said, okay, well, therefore, could I not apply this to a universe? If I knew the matter distribution of the entire universe, would my theory tell me the history, the past, present and future of the universe? And it turns out that you might say, well, I can't do that. How can I decide to know what the distribution of matter in the universe is? So what Einstein and a Belgian priest, actually, called Georges Lemaitre, and some others did, was say, well, we'll make the simplest assumption, which is that it's uniformly distributed on large scales. So everywhere you look, it's roughly speaking the same. And the theory tells you that the universe is either expanding or contracting. In other words, it tells you that there was an origin, because if you've got an expanding universe today, it means it was smaller in the past. So the theory actually predicted the Big Bang, the origin of the universe.
The cost of hero worship. Rewriting history erodes scientific merit. Giving Einstein credit for others' breakthroughs distorts science. Lemaitre's contribution was not merely interpretive, it was a major theoretical advance. He was the first to derive what would become the Big Bang model from Einstein's equations. Science must credit ideas, not icons. Big Bang's deep problems. Even the Big Bang needs a rethink. Let's go deeper. Even the Big Bang model, despite Lemaitre's insight, is flawed. It requires inflation, dark matter, and dark energy, three placeholders for gaps in the model. The complexity is enormous, and the metaphysical implications of singularities and quantum vacuums go unaddressed. It's time to reconsider the entire cosmogenesis narrative. A new cosmogenesis. The hypergeometrical universe, a simpler beginning. I present the Big Pop cosmogenesis, part of the hypergeometrical universe theory, WHO. It's a quantum mechanical model with a real topology. The universe is a light-speed expanding hyperspherical hypersurface. No singularity, no inflation, no metaphysical assumptions, just Heisenberg's principle and the elasticity of space. Metric fluctuation, not singularity. The universe began with a hyperspherical metric fluctuation. Instead of a singularity, WHO starts with a 4D metric fluctuation, 662 light-seconds in radius. It has a contracting outer layer and a dilating inner one. These cancel energetically. There is no need for infinite densities or energy. This fluctuation recombines to create all matter in the universe. That moment, the Big Pop, is the real beginning. Matter as deformed space. Fundamental dilators. Space itself creates matter. In WHO, matter is a coherence of deformed space, called fundamental dilators, FDS. These are not particles in space, they are space in a different form. This approach eliminates the need for quantum fields, inflation fields, or dark components. The universe is made of space, deformed space, and time. The figures represent WHO's four fundamental particles. They are distinct phases of the fundamental dilator coherence. In other words, depending upon which phase is in phase with the universe, a different particle will result. The whole universe shifts from matter to antimatter every half cycle of the fundamental dilator coherence. Matter or antimatter is just a matter of phase and mapped to dilation or contraction. Notice that this specific assignment is only relevant at the time when the outermost contraction layer, one of the two remnants of the Big Pop cosmogenesis, fragmented into a blackholium. Blackholium is a hypersphere-shaped black hole, to distinguish it from the spherical black holes. Matter as shape-shifting, spinning deformations of space is a superior paradigm to mass-deformed spacetime. The reason is simple. This paradigm simplifies physics and allowed WHO to derive the laws of nature from first principles. Quantum Lagrangian principle. A new law of motion. The quantum Lagrangian principle, QLP, replaces Newton's laws. It states, FDS moved to remain in phase with the local dilaton field. This defines motion and explains forces in a universe where all particles surf the expanding hyperspherical wavefront. The left panel shows two interacting masses of fundamental dilators traveling at the speed of light radially, perpendicularly to our 3D universe or hypersphere. As they tunnel from state to state, they produce metric waves, the dilaton field. Who refutes the standard interaction paradigm through arbitrary bosons. Instead, Who proposes that interaction happens through the dilaton field and the quantum Lagrangian principle. The quantum Lagrangian principle, QLP, is a no-work paradigm. It just states that particles shouldn't do work just to exist. If they did, they would dissipate. Because of that, QLP states that fundamental dilators will move into positions where they dilate space in phase with the local dilaton field. That is shown in the right panel, where the fundamental dilator has to choose which crest to join. In the large N, large number of fundamental dilators, approximation, the body on the right has many dilators and their interference pattern is equivalent to de Broglie wavelength mass dependence. In other words, a large number of dilators will produce crests that are close together, and that is equivalent to having a wavelength that is inversely proportional to the mass. The dilator will always choose the side that lowered the deformation of space. In the case of opposite charges, the fundamental dilator will be attracted to each other. Epoch-dependent gravity. Gravity isn't constant, it's evolving. Who shows that g, the gravitational constant, is epoch-dependent. This simple insight explains supernova data, early galaxy formation, and the great attractor's velocity field without invoking dark energy. As the 4D radius grows, gravity weakens. This means that in the past, gravitation was stronger. Type 1a supernova, SN1a, detonates when they reach the Chandrasekhar mass limit, and that has a g to -3/2. So, the farther the SN1a, the smaller their masses and weaker their absolute luminosity. This led to the consistent overestimation of SN1a distances and the current crisis in cosmology, which is actually a crisis in physics since relativity is wrong and will have to be dropped. Returning to the figure, this represents a cross-section of the 4D lightspeed expanding hyperspherical universe. The quantum Lagrangian principle demands that the fundamental dilator to move x to the right because of some interaction. Suppose the original direction of propagation was along the radial direction. One can move x to the side and change the angle by α1, α0. α0 would correspond to the fundamental dilator just slide over by x. α1 correspond to a large change of direction. In LeHu, a change in direction corresponds to an acceleration. Who starts from calculating accelerations, and from there it derives the forces. This is possible because the fundamental dilator is mapped to a hydrogen atom, which is what we see in 4D. In other words, the difference between gravitation, sliding sideways by α0, and electromagnetism, twisting the direction of propagation by alpha 1, is how the fundamental dilator responds to the field. The field is the same. The case of gravitation corresponds to the interaction of neutral moieties. I used the hydrogen atom as the archetypal gravitation fundamental dilator. Ideally, there wouldn't be any force between them, and the orientation of the direction of propagation would always be aligned with the radial direction, since that corresponds to a particle at rest. That explains the sliding over nature of the gravitational fundamental dilator to the dilaton field. The distinction in scale between gravitation and electromagnetism maps to the ratio between λ1, Compton wavelength of a hydrogen atom, and the 4D radius of the universe, 14. 5 billion light-years. Notice that alpha 0 is equal to x divided by r0. This makes gravitation epoch dependent. It depends upon the 4D radius at a given time. So, who presents a trivial and clear reason why Newton's gravitational constant is inversely proportional to the 4D radius of the universe? Replacing the Big Bang. From complexity to clarity. Instead of singularity, false vacuums, or inflaton fields, who proposes? Metric fluctuation from Heisenberg. Partial recombination, Big Pop. Creation of blackholium, hyperspherical black hole. Neutronium phase transition right pointing arrow acoustic oscillations, CMB origins. Neutronium decay right pointing arrow hydrogen plasma right pointing arrow transparency epoch. The Big Pop cosmogenesis. Who proposes that the universe started with a simple Heisenberg principle-driven hyperspherical metric fluctuation of 421 light-second 4D radius. The universe starts from a Heisenberg principle-dictated metric fluctuation having a contraction in the outer layers and dilation in the inner layers, which partially recombines. The recombination process is called the Big Pop. After the partial recombination, the remaining layers of the inner dilation layer and the outermost contraction layer are universe. Blackholium is a hyperspherical hypersuperficial black hole. Neutronium is a similarly shaped neutron star. Notice that as the universe expands, density decreases in a predictable manner. Summary. Restoring scientific integrity and simplifying cosmogenesis. We've seen two things today. BrianCox perpetuates a harmful myth: Einstein never predicted the Big Bang. The Big Pop cosmogenesis offers a cleaner, simpler, testable alternative grounded in geometry, quantum mechanics, and observable data. Who reclaims the integrity of science by restoring credit to Lemaitre and offering a framework that explains the universe from first principles.
My name is Marco Pereira. In 2005 I created the hypergeometrical universe theory. The hypergeometrical universe theory was the result of exploring not the most sophisticated possible model but the simplest one. It wasn't clear to me why the proverbial balloon a light-speed expanding hyperspherical universe topology or LEHU, wasn't part of the discussion. I wasn't happy with the Big Bang model and decided to explore LEHU as an alternative. In doing so, I realized that for me to create a 4D model for electromagnetism, the mass of the electron would have to be around 1 atomic mass unit, or the mass of a hydrogen atom. I put 1 and 1 to make 2 and proposed a new model for matter in a 4-dimensional universe. That was the motivation for the fundamental dilator. This path leads to the simplest possible understanding of the universe, the most fundamental theory of everything. My theory is expansive and touch many areas. That said, I am sure there is still work to be done and future generations will be able to expand upon what I did. The hypergeometrical universe theory contains 3 hypotheses. The universe is a light-speed expanding hyperspherical hypersurface. Here you can see yourself at position A, looking into the sky, and seeing light emitted by a Type 1a supernova, SN1a. When it was at position B and the universe was smaller 4D radius, denser, and more homogeneous. Notice that the universe and all its stuff is at the hyperspherical shell locus and that locus expands at the speed of light. Notice that there isn't any brain, structure connecting galaxies, etc. Who shows that the receding of galaxies is because they act exactly like dots on a balloon. That is, they travel along the radial direction, perpendicularly to our 3D space. Hence, Who does not use or need dark matter, dark energy to explain reality. The second hypothesis states that matter is made directly and simply from localized, shape-shifting deformations of space. The monomeric unit is called fundamental dilator, FD. FD is a coherence between stationary states of deformation of space. Notice that I said space and not spacetime. Spacetime plays no role in the hypergeometrical universe theory. Here you can see the fundamental dilator representations of the electron and positron particles. The letters orientation maps the phases orientation with respect to our 3D universe. Vertical letters indicate that that phase is perpendicular to our 3D universe and does not interact. The closed loop indicates that the coherence will repeat for the lifetime of the particle. Here you can see the fundamental dilator representations of the proton and antiproton particles. Neutrons contain fundamental dilators for electron and proton plus 2 transmutation chords, shown in red. The transmutation chords correspond to half antineutrino each and map to rotations within the 3D hypersurface, as opposed to spin. Notice that W- is just a state in the decay process. One can understand this in terms of transition state theory. Now that you know that in the hypergeometrical universe theory, matter is made directly and simply from deformed space, it becomes clear that the universe contains only space, deformed space and time. That is the simplest possible model, and because of that, HU is the fundamental theory of everything. Immediately, it becomes clear that all matter in the universe could be created from a fragmented deformation of space. More specifically, since our observable universe is clearly tri-dimensional, the universe started as a Heisenberg-dictated 4D hyperspherical metric fluctuation. The deformation configuration that is consistent with the creation of the universe contains dilation in the inner layers and contraction in the outer layers, not unlike Prince Rupert drop. Immediately after the formation of the initial metric fluctuation, partial recombination took place. Since the 4D radius of the universe was 421 light seconds, the partial recombination took 421 seconds to occur, leaving just 2 layers, the inner dilation layer or IDL and the outermost contraction layer or OCL. The inner dilation layer contains the negative energy that is missing in our universe. Energy conservation is used to calculate the 4D radius using a maximum density, black hole density, predicted by HU. All particles in the universe surf the inner dilation layer. That is covered in the Silver Surfer paradigm for motion. Once the partial recombination occurred, the only inner layer, the inner dilation layer, pushed the outermost contraction layer and fragmented it, giving rise to the blackholium. Blackholium is a new name because I needed to distinguish this black hole shaped as a hyperspherical shell from the garden variety black hole, which is spherical. Inertial motion or natural velocity motion made the blackholium to continue its forever expansion. Of course, forever here means for the lifetime of this universe cycle. Humpty Dumpty sat on a wall. Humpty Dumpty had a great fall. All the king's horses and all the king's men couldn't put Humpty together again. Immediately, it becomes clear that as the blackholium expands, it will eventually become a neutronium, hyperspherical shell-shaped neutron star. That will be a phase transition since suddenly matter will become neutron matter and acquire an internal, orbital, degree of freedom. That is when hyperspherical harmonic neutronium acoustic oscillations are triggered. Further expansion will lead to the freezing of these NAO, neutronium acoustic oscillations, since at 300 MeV per cubic femtometer, the sound velocity suddenly decreases. This is the source of the cosmic microwave background features. On the top you can see the Planck satellite observation. HU simulated hyperspherical harmonics and sampled the density modulations at the locus of the CMB, approximately 1,4D radius from us. So, HU simulated 4D acoustic waves and measured their effect on a 2D spherical surface embedded within the hyperspherical shell. The simulated fluctuation on the left is due to the freezing of the neutronium acoustic oscillations, and it is a small component, 1 in 100,000 parts, of the energy released upon neutronium decay. Neutronium decays when its density is such that neutrons become free and decay into protons, electrons and antineutrinos, releasing 0.78 MeV of kinetic energy. That is when the universe gets hot. That happens at the end of the first day in the life cycle of this universe. Notice that HU Big Pop cosmogenesis is a cyclic model, driven by Heisenberg-dictated metric fluctuations and eventual recombination of the positive and negative space deformations. So, up to the end of the first day in this universe cycle, the universe was cold. It started without a single internal degree of freedom, which corresponds to 0 Kelvin temperature. It gained orbital angular degree of freedom when the blackholium phase transitioned into the neutronium. Hyperspherical harmonic acoustic oscillations were triggered at that point. These acoustic oscillations are not the standard baryonic acoustic oscillations or BAO, since they occurred in a phase, cold neutronium, that has no equivalent in the Big Bang model. The appropriate name for them is neutronium acoustic oscillations, or NAO. Baryonic acoustic oscillations take place when the neutronium decays, releasing all its energy. HU doesn't need to change anything in the modeling of baryonic acoustic oscillations or the CMB spherical harmonic spectrum. HU allows for the use of Einstein's work where it works, locally. All phenomenon described within the CMB modeling are local phenomenon. HU derives a simpler and distinct cosmic distance ladder or cosmological ruler. It has the CMB occurring when the universe was 11 million years old and 3,400 Kelvin. HU used Saha equilibrium model to derive the recombination density and temperature. Further refinement can be achieved by using non-equilibrium conditions. These are HU conditions at the recombination epoch, 11 million years after the Big Pop. There you have it, a simple explanation on how the universe was created without any energy or breaking any law of physics.
The hypergeometrical universe theory, HU, replaced it with an elegant model that explains everything and offends no law of nature.